In this video, we're going to run through the process to create the model and toolpaths that would allow you to cut the part you can see on the screen here with a rotary axis set up on a CNC. I'm going to start by doing the standard wrap job setup so that we can orient and size the part correctly. Then we're going to import a simple set of vectors, do a swept shape and show you how to create toolpaths on that version of the object. Then we're going to make some edits to the design to introduce the box-shaped cross-section at the top and the octagonal part you can see on the bulging shape in the middle here, and then look at how we can simply recalculate the toolpaths in order to take into account the changes we've made to the design. Let's go ahead and start a copy of Aspire. So as with any rotary job, we're going to set up the part by coming up to the Gadgets drop-down menu, going to Wrapping, and choosing the option for the wrapped job setup. This will bring up a special form that we can fill in order to specify the size and the orientation for our part relative to the machine. So in this case, I'm going to create a part which is 26 inches long. The cylinder diameter, or our stock diameter, is going to be 4 inches. So you can see there we have the units checked for inch. Next is very important, we choose whether we're going to wrap the Y values around the rotary axis or wrap the X values around the rotary axis. The one that you choose here is going to be totally dependent on the orientation of your CNC rotary axis. So you'll need to check with the manufacturer or look at your CNC in order to see which one of these options it uses. For the purposes of the video, we're going to use the first option here, which will keep the linear axis along X and wrap the Y values around the cylinder. I'm going to set our drawing origin, so XY0, into the lower left corner, and we're going to choose the cylinder axis to be Z0. Typically, this is going to be the most reliable choice. It's much harder to set your Z0 off the outside edge of the cylinder because that requires your cylinder to be a perfect circle for that to be correct. So typically, going to use the cylinder axis, and this is the equivalent in the software of setting the bottom of the block to be Z0 on a regular 3-axis job. Going to do a standard cylindrical wrap, so this is where we cut a straight line along the cylinder and unwrap it. You do have the option of a spiral wrap over towards the right here. So with all that selected, let's hit OK. The software will automatically generate the right size job for us. Whenever we're working within Aspire on a rotary job, it's always going to effectively be in a 3-axis environment. So we're going to model the parts and create the toolpaths in a standard XYZ 3-axis orientation. We will have the ability to preview and see what the part will look like when the Y-axis is wrapped around the rotary, but the only time that wrapping will actually occur is when we choose a post-processor that has that wrapping ability built into it that's appropriate for our particular CNC, and we save the toolpaths. Until then, the software really only considers this to be a 3-axis job. We just happen to have the ability to view that as if it's wrapped around the cylinder. When we use the wrapped setup gadget to create our job layout, then it automatically generates a couple of layers and some vectors. If we just use the drop down here, you can see if I switch on this first layer here, then that's called 2-rail sweep rails, and that's a blue rail on the left and the right of our design. We are going to use those in a moment. If we switch on the other layer that's automatically created, that's called bounding box and has this red vector around the outside of the job space. I'm not going to use that in this job, so I'm going to click the right mouse button over that and go to delete and choose the option to delete the data and hit OK. So now we've just got rid of that layer. Next, we're going to import the vector that's going to give us the basic shape for the job that we're going to wrap. I'm going to come up and click on the icon to import vectors from a file, and in the project folder you'll find a file called rotaryprofile.eps. If we hit open, you can see that's been imported here. Its lower left corner is at XY0. As I say, this represents the basic profile for our part, and I pre-drew this in the software before exporting it. So when you're creating a part using the wrapped rotary setup, the first job you may have is to sketch out or draw the vectors that you need for the basic profile. I've just shortcut that process here, and you can see the vectors we're going to use at the bottom of the screen. just going to click to deselect those, and what I'm going to do for the moment is just click again on them and click once more to go into transform mode, and holding the shift key on the keyboard I'm going to click again and just drag that downwards, and holding shift means that it will stay vertically in line as I drag down. It's just to drag it out the way of my main work area, so it's just to keep things a little bit more tidy. So we have all the vectors we need at this point to create a simple swept shape, and then to show you that in the Rotary and to create some toolpaths on it. Before we go ahead and create the component, I'm just going to do a bit of layer management. So we'll come down to the layer manager here. You can see I have nothing on layer 1 at the moment, so I'm going to right mouse click and delete that. Going to right mouse click on this import layer that was created when we imported that vector and say rename, and we'll just call that Rotary Profile. Just keep things well managed, nice and simple. Now I'm going to create one more new layer, and I'm going to call that Components. Just click to accept that, and I'm going to move that to the top of the list, and we'll leave that selected as our active layer. That means that as we create the next 3D shape, the grayscale for that will be put onto that layer. It won't obscure any of the vectors that are on layers further down in the list, and it'll be easy for me to switch the grayscale off without having to switch off the whole 3D component. So I'll say we've got this components layer selected, that's active. Now we can come down and click on the modeling tab. We're going to use the 2-rail sweep tool, so I'm going to click on that, and the first thing is to select the 2 rails, and that's the ones that were automatically created for us when we set up our wrap job. So I'm going to select the blue line on the left, shift and select the blue line on the right, click on the button to use selection. I'm going to make sure scale cross section with width is unchecked, sweep between spans is checked. Then I'm going to come down and select what I'm going to use as my cross section. So now this shape will be swept along those 2 straight lines, and we'll call this main profile and hit apply. So there we can see a grayscale has been created in the 2D view. If I want, I could go up to view, and we can tile the windows horizontal so I can see the 2D view at the top and the 3D view at the bottom, and we can see the shape that's been generated there a little bit more clearly in the 3D view. If that looks correct, then we can hit close. You can see there that that shape has now been added to what's called level 1 here. To keep things organised, let's just right mouse click on that, rename that, and we'll call that basic shape. So this just helps us to maintain some organisation on the part. Now at this stage we can still see the part shown in the sort of 3-axis environment with linear X, linear Y and linear Z. As I mentioned before, we have the ability to view this in a rotary view in the software. The way to do that is to put the focus on the 3D view. You need to make sure that the 3D view is selected there so that you can do this. We come up to Toolpaths, Toolpath Drawing, and from within here we come down to the selection where at the moment we've got wrapping off checked. We can choose to show it with the Y values wrapped around or the X values wrapped around, and this is again down to how we set the part up originally. So we chose to wrap the Y values around the X, so if I click on that we can see the part that we've generated there shown in that orientation, and I get a good sense of what the part will look like that we're going to actually create the toolpaths on. To create the toolpaths though, I do need to be back in the standard 3-axis view, so I'm going to come up to Toolpaths, Toolpath Drawing, and switch the wrapping off and just click on the ISO view there to go back to the standard view. And at this stage we could go over to the Toolpaths tab and calculate a roughing and finishing toolpath, and we'd have all we need to cut this part. In this case though, we have a number of areas on the part which will effectively create a flat surface. So at the bottom here, in this area, and also in this groove here between where the part ends and the work holding starts. To get the best result, it would be ideal if I could create 2D toolpaths to cut those areas rather than 3D. Now although this area here is flat, later on in this tutorial I'm going to show you how to generate a shape for that will give us a square profile when it's machined, so I'm not going to worry about doing 2D machining for that. So before we calculate the toolpaths, let's create some boundaries that are going to help us be a bit more efficient in how we calculate them. Let's come back to the drawing view, the drawing tab rather. Let's click on the 2D view, hit F to fit this into the 2D view window as efficiently as possible. So let's do a little bit of layer management to keep all our entities organized. Let's click on the layer drop down here. I'm just going to undraw the components layer, so that removes the grayscale from the 2D view. I'm also going to undraw the 2 rail sweeps rails layer as well. I'm going to click on the button to add a new layer, and I'm going to call this 2D pocket. Let's just correct the capital there, and we'll just click to accept that, and we'll make sure that is the currently selected layer. Let's close the layer manager, and before we actually draw the vectors for this, I'm going to use the guidelines to help me pick up some of the key positions from the profile that we have at the bottom here. So I'm going to start with some vertical guidelines. So I'm going to click on the rule over on the left here, drag off, and I'm just going to make sure that I snap to that point on the geometry there. Then we let go and we've created a guideline. Now to create a copy of the guideline, I can just hold the control key down, click and drag, and snap to the point there. I'm going to click and drag and snap to the point here, 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 and then at the very end there. And actually there's one more I'd like, so we'll just click on that and drag along into here until we snap to the point there. So I did that fairly quickly. If you just want to take a moment, you could always pause the video at this point and just take your time to put a vertical guideline in each of those locations. Now we're not going to use all of these straight away, but we'll come back to some of them later. The other type of guidelines I want are horizontal ones at the top and the bottom. So I'm going to click on the horizontal ruler at the top and drag down, snap that to 0, then click here and snap into the corner there so that it picks up the very edge point. So now I've got a horizontal guideline across the bottom and the top, and all these vertical guidelines snapped to some key positions on my profile. Now we have those guidelines in place. If you remember, we've got the 2D pocket layer set up as our active layer, so I'm going to create 3 vectors that represents areas that I want to pocket out when we come to do the toolpathing. So I'm going to click on the draw rectangle tool. I'm going to come up and snap to the point here, so you see I get 2 lines on the crosshair when I get to an intersection of the guidelines. I can click in that corner and drag down and let go in that corner there. Then I'm going to come over to this one here, so click in the top there, drag down to the bottom there, and then finally I'm going to come over and go to the one at the end here. Now if we just close that, it's a little difficult to see those vectors at the moment. What we can do is come down and perhaps change the color to something like orange. Then if I hit close and we just click there, we can see those orange vectors have been created. If I want, I can just toggle the guidelines off by clicking where the 2 rulers intersect here in the corner. We can see those 3 shapes there. So they look good. The next thing I want to do is create some shapes that are going to be the boundaries for the 3D machining, and that'll be the area here and here. Now we can come into the layer manager, add a new layer, and we'll call this 3D boundary. Just click to accept that, and let's perhaps change the color of this to be a green color. Hit close. Then I'm going to click on the icon to draw rectangle. I'm going to click in the corner here and drag down to the corner there. I'm going to hit the space bar to accept that, and then click here and drag down there. And then I'm just going to hit apply and close. And now you can see we've got those vectors. If we work by switching off the different layers, we can see those vectors are in position now. Now just before we go over to the Toolpath tab, one thing that can be beneficial when doing rotary machining is to come slightly past the edge of your part in order to make sure that you don't leave any kind of a seam at the top or bottom, basically where the part wraps around and joins up. To help us do that, I'm just going to slightly increase the height of the 2D pocket vectors. So let's use the drop down for the layer manager here, click on the icon at the end, and we'll choose the option to select layer vectors. So that's on the 2D pocket layer. If I close that now with those vectors selected, I can click on the icon to set selected object size. I'm going to anchor around the center unlink X and Y because I don't want to change the width, and we'll just change the height here to 13 inches, hit apply and close. So now we've created boundaries that come slightly past the top and bottom edge of the part. I don't need to worry about that for the 3D boundaries because I'm going to use the ability in there to offset past the boundary with the toolpath when we calculate it. So let's just click to deselect there. Now at this point I've got all the boundaries that I need for my toolpathing, and also, if you remember, we've got our 3D model as well. Although we undrew the grayscale, that doesn't affect the visibility of the 3D model. That's affected purely by whether we have it switched on or not in the component tree. So let's tile the windows so we can see the 2D view at the top, 3D view at the bottom. Click on the icon to switch to the Toolpaths tab. Please note that if you do plan to cut this job, then it's very important that you make sure you use parameters that are safe and appropriate for your machine, the rotary axis set up on it, the tooling you have available, and the material you plan to use. Before we calculate any toolpaths, the first thing to check is the material setup. So let's come over and click on the set button here. Now mostly we're just checking the values in here because this will have been defined when we did our wrap job setup. We told it we wanted to use the center of the cylinder for Z0, and that's the equivalent of the bottom of the block, so we can see that's correct. The diameter of our cylinder was 4 inches, which is the equivalent of 2-inch thick material in the 3-axis environment, and our XY 0 position is going to be in the lower left. The model that we're working with here is the same thickness as our material, so there is nothing to adjust in terms of where that sits in position there. If it's less than the thickness of the material, then you'll typically want to drag that down to the bottom of the block with this particular setup. Lastly, we check our rapid gaps here and make sure the home position is at least the thickness of the material plus the highest of our rapid Z gaps, so that we make sure that we can clear the block here and any clamping that we have. So if we set this to 2.5, that should be correct. 2 inches plus the ½ inch here for the clearance, so that's an appropriate value. Once we've checked all those, we can hit the OK button. Now we're ready to calculate our first toolpath, which in this case is going to be a 3D roughing to hog out the majority of the material in the part. So if we come up and click on the icon for 3D roughing, I'm going to hit select, I'm going to choose a 1/4 inch end mill, and I'm just going to override the value in the tool database and set the pass depth to be 1/4 inch. I'm not going to worry about the speeds and feeds here because I don't actually plan to cut this. If we hit OK, I'm going to choose the model boundary in order to select the area we're going to machine, and 0 boundary offset in this case. Machining allowance I'm going to set to 0.05 inch, and now we have the choice of the direction we want to raster in, assuming we're going to do a Z-level cut. If we raster in X, that means the tool is going to move along the X-axis before stepping over. Now this direction is very important when we're doing a rotary setup, because what that means is it will machine along the part, and then there will be a short rotary move, which is the equivalent of the step over, and then it will raster back again. If we change this to raster Y, so that the toolpath was going in this direction, that would be the equivalent of the part spinning all the way around with the tool, then stepping over in X, then spinning all the way back again. So it really depends how you want to machine. For most people's setups, they're probably going to choose the raster X to go along and then have a short rotary move to turn and raster back again. Not going to worry about ramping at this stage. Let's just go ahead and provide a name here, 3D roughing, and hit the calculate button. So the software's automatically opened our preview toolpath form and drawn that toolpath in the 3D view. If we want, we can maximize this now and take a look at the toolpath hogging out the material, and we can go ahead and run the preview. So if we click on that, we'll see the result of running that roughing toolpath. So once I'm happy with the way that looks, I could also view it in the rotary environment, go to Toolpaths, Toolpath Drawing, Wrap Y Values in this case, so we can see how the part's going to look after the roughing there. That looks okay, so let's go back to View, Toolpaths, Toolpath Drawing, and Wrapping Off. Now I'd like to calculate the pocket toolpaths to machine down the flat areas. So let's just close the preview toolpaths form, click on the icon here to switch back to the drawing tab. We'll just click on the 2D view and hit the icon to zoom to fit. Now I just want to take a couple of measurements from the profile vector here so that I know the depth of cut I want for each of my 2D pockets. So let's come over and click on the icon for the measure tool. I know with the way I've drawn this that this surface here, or this line here, is the equivalent of the outside of my cylinder. So if I click on that first to create an anchor point and move the cursor down here and click there, I can see that the Y distance from the top or from the outside edge of my cylinder down to that point there is 1.075 inches. So that's going to be the depth of cut for that pocket, and I'll just make a note of that. For the next one, I'm going to click here, come over here and click, and I can see that is a distance of 1.25 inches in Y. And then for the last one, I'm going to come over and click here, and that is a distance of 1.5 inches. So I just need to make a note of each of these so that I can use it when I calculate what is going to be 3 pocket toolpaths to machine down those areas. So let's close the measure form, click on the icon to switch back to the Toolpaths tab. We'll go back to our tiled view, tile the windows horizontally. So as I say, I want to create 3 pocket toolpaths for those, and I could 3D machine these, but it's much more efficient to use a 2D toolpath when you can to machine a 2D area. So if you've got profiles, it would be more efficient to do profiling, and if you have flat areas like this, it's more efficient to use a pocket. So let's select the first vector, click on the icon to go into the pocket toolpath form. Start depth for this is going to be already most of the way cut down. So what I could do is specify something like a start depth of say 1, and then the cut depth is just going to be the difference between that and the actual depth of cut I want to get to, which if you remember was 1.075. So that just means I'm going to get a single pass in order to pocket down to that level. If I hit select, then I can choose the 1/4 inch end mill from here and hit OK. I'm going to choose a raster pattern in this case, and I'm going to raster along X, so I'm going to raster angle of 0. I'm not going to worry about the other options. We'll just call this pocket 1, hit calculate, and there we can see that toolpath's been created. Let's just close this. We won't preview this yet. We'll just go ahead and select the next one, click on the pocket toolpath icon. For this one, I want to cut down to a depth of 1.25 inches, so I could specify a start depth of 1 again and a cut depth of 0.25. I can take all the other parameters as we entered them before, and we'll just call this pocket 2 and hit calculate there. Close this, and for the last one here, we'll click on the pocket icon again. This time I want to go down 1.25 with an additional cut depth of 0.25, so a total machining depth of 1.5 inches from the top of the block. Again, we'll use the same settings and just provide a name at the bottom there and hit calculate. Now we could take those 3 toolpaths we've got there, they're all checked so they're visible, click on the icon here to preview visible toolpaths, and that's not going to look too exciting there because we're basically just getting our 3 flat levels machined. Last thing I want to do for this first iteration of the job is to create my 3D finishing toolpaths. So if we close this form here, what I can do now is select the 2 vectors for the boundary of the 3D toolpaths. If you want, you could make that simpler by going to the layer manager, which I can do by hitting Ctrl L on the keyboard, and I could switch off the 2D pocket layer, just leaving the 3D boundary layer on, so that would make that easier to select if I want to. Let's just go back to the Toolpath Manager by hitting F12 on the keyboard there. So we have the 2 boundaries selected for our 3D. I'm going to click on the icon for 3D finishing. I'm going to select quite a large ball nose tool for this. We'll use a 1/4 inch ball nose tool. We'll take the default parameters and hit OK. This time I want to use the selected vectors. So we're using vectors to limit the area we're going to machine, and I'll put in a boundary offset of 0.1 to come a little bit past the edge of those vectors. I'm going to raster parallel to X, so raster angle 0, and we'll just call that toolpath 3D finish and hit calculate. So there we can see the toolpath drawn in the 3D view, Software's opened the preview form again, and so now if we want, we could just maximize that, preview the selected toolpath. We can see that being machined, and once that's done, we can go ahead and look at that again using the toolpath drawing for the wrapped view. So if we like the way that looks, toolpath, toolpath drawing, wrap Y values around, and there we can see that is what we should be getting if we were to output these toolpaths now and machine them on our rotary axis. If we did want to save these, then we could close the preview there, select the toolpath we wanted to output, click on the icon to save the toolpaths, and then it would just be a case of choosing the appropriate post processor from the list for your particular machine. Now it's very important to note that it has to be a post processor that supports rotary moves. This is the stage where the software is going to take what are essentially 3-axis calculated toolpaths and then convert those into the rotary. So the post processor has to support rotary, and it has to be set up so that it's configured correctly for whatever your rotary axis is. If we have a look here, let's just hit M to search for post beginning with M. We can see for the Mac 2.3 control program, we've got these special posts here, some here that are set to wrap X to A and some that are set to wrap Y to A. In our case, we're wrapping the Y axis, so we'd actually choose something like that where we're wrapping the Y values to A being a typical designator in G-code for a rotary move. Once we've chosen the appropriate post, we can click on the Save Toolpaths button, and it will just pop up this form to give us a reminder of our settings so that we can just double check that they are correct. When we hit OK, it will now allow us to save that toolpath as a file that we could take out and run on the rotary axis on our CNC. I'm not going to save the file in this case, I'm just going to hit cancel, and we would just proceed through the list in order to save all of these out. We could, if we want in this case, actually save out all these first 4 toolpaths in a single file because they all use a 1/4 inch end mill. So there's various options here. It's just getting familiar with those output options there. So let's go back to output a single toolpath and switch off the visibility here. Let's go ahead and close the Save Toolpaths form. So you've seen there the process for using a simple swept vector in order to create our 3D geometry, and then how we can calculate 3D roughing, 2D pockets and the 3D finish toolpath to cut it. What I'd like to do now is take this and create a slight variation on the shape that we've got here and create a box shaped section at the top of our spindle and add an octagonal kind of shape to this bulging section in the middle here. To do that, it's going to require me to use something called the Vector Unwrapper, which is another one of the gadgets that's been created to help us when doing a wrap job. Let's just go back to an ISO view, go up to Toolpaths, switch off the wrapping, click on the icon to switch back to the drawing tab over here, and again we'll just tile the windows so we can see the 2D view at the top and the 3D view at the bottom. The Vector Unwrapper requires me to draw a vector which represents the cross section as I want to see the object once it's been wrapped. So to create a box in the wrapped environment, I need to draw a square and then use it to unwrap that to give me the vector that I can sweep in the 3-axis environment to give me the right shape. So to help me get these shapes, I'm going to do a bit more measurement on my profile. So let's select the profile, click on the icon to zoom selected, just click to deselect, come down to the measure tool, and the first thing I want to do is measure the vertical distance from the center of the part to what's going to be the face of my box section here. So if I click there, I can see that's a Y distance of 1.4. So I'm going to need a square which is 2.8 inches across the flats. Then while we're in here, let's also measure the distances for the bulging area that we've got as well here. So I'm going to click over on the bottom and click here, and I can see that's got a distance of 0.75, so I'm going to need an octagon which is 1.5 across to represent that area. And if I click here again on the bottom and click up here, I can see that's a distance of 1.75, so doubling that to give me the full distance across the part will be 3.5 inches. So you'll see the effect of these measurements in a moment when we come to create the shapes. Right now I just want to take a note of those, so 1.4 here, or 2.8 across, 0.75 or 1.5 across, and 1.75 or 3.5 inches across there. Let's close that now, click in the 2D view and hit F to go back to fit that into our main 2D window. Let's just maximise the 2D view for a minute and hit F again to just work a little bit more easily in here. So I'll say my first cross section is going to be derived from a box which is 2.8 inches across. So let's click on the Draw Rectangle tool. We'll enter a rectangle which is 2.8 by 2.8 and hit Create and Close. And you can see that's just been created at 0, 0 there. When I unwrap a vector, it has to be in the middle of the job, so I'm going to select that and hit F9 on the keyboard in order to position it there. Now just before we unwrap it, I want to show you that I've basically created my design here to ensure that this square will fit into the cylinder of material we're working with. You need to be aware that obviously the points have to sit inside of that overall cylinder. So if I just draw a circle which is 4 inches in diameter and just click in the center of the part there and right mouse click to accept that, that's the diameter of the material we're working with, and you can see there that I've just got a little bit of clearance with my box cross section in order to fit in that when we create the toolpaths for this. So you may need to just double check that if you're not sure what that size is going to be. Just going to click and delete that. Now I'm ready to unwrap this vector, so I'm going to select it, come up to Gadgets, Wrapping and Vector Unwrapper. And what that will do is it will create this vector you can see here, and it'll also create some more vectors on some additional layers that we'll look at in a moment. I'm just going to take and click this vector, and I'm going to rotate that 90 degrees, and I'm going to do that by hitting 9 on the keyboard twice, and that's just going to rotate that round 45 degrees at a time. I'm just going to click and drag to move that down the bottom of my part here. Let's hit F in order to fit that in. Now I'm going to delete the vector I used to represent that shape. I don't need that. And let's just look here at the layers that have been created by this unwrapping operation. I've got one layer with the unwrapped vectors on, which is okay. I can see that there at the bottom. If I switch that on and off, I've got another layer with some more drive rails on it. Now I don't plan to use these. I need to limit the area I'm going to sweep this along. So I'm going to right mouse click, delete that drive rails layer and delete the data on it as well, just to keep things nice and tidy. Next we'll come back to the layer manager here, and I'm just going to undraw the visibility of the 3D boundary layer. I don't need that switched on at the moment, and I'm going to add a new layer in here, and we'll call this Rails, and let's change the color here. We'll make this a kind of an orange color and hit Close. Now I'm going to click the box in the corner of the tool rules here to switch back on my guidelines, and with this Rails layer current, I'm going to click on the icon here to draw polylines. Now what I want to do is create a couple of rails which we're going to use to sweep our shape that we just created along. So the box section is between these two areas here, so I'm going to click at the intersection of the guides there and then click here. I'm going to hit space to create that line, come up the top and click at the intersection there and click at the intersection there, and then right mouse click in order to create those lines and exit the function. Now I'm just going to uncheck to switch off the guidelines. So I've got these two vectors we've just created there, a little difficult to see them. Now I'm ready to sweep my shape. So I'm going to come back into the layer manager. I'm going to go up and switch on the components layer for the grayscales again and just make that the active layer. Now that means when we create the shape, the grayscale will also be placed on that layer as well. Let's tile the windows now so we can see the 2D view at the top and the 3D view at the bottom. I'm just going to come down to the modeling tab, and for a moment I'm going to switch off the level that has got my basic shape on it. I'm going to right mouse click here and insert a new level, right mouse click, rename that level, and we'll call that decorative shapes. And I'm going to use that level to create my new components on. Now we can click on the icon for the 2-rail sweep. I'm going to select this drive rail, shift and select this drive rail, click on the use selection button, and then I'm going to select this for my cross section. Make sure scale is unchecked, sweep is on, and I'm going to set this component to merge with the other components. So we'll call this box section and hit apply and close. Now we can see that's created quite an odd looking shape, but if we come up and just maximize the 3D view, then come up to Toolpaths, Toolpath Drawing, wrap Y values around, you can see that that shape, when wrapped around, gives me the box section of the size of that original vector that we used the vector unwrapper for in order to generate that cross section. So that's essentially how the vector unwrapper works. Now if I want, I can switch back on my basic shape. At the moment we've got the level for the decorative shape set to add, so I'm getting quite an odd result. I'm just going to right mouse click on that, change its combine mode to merge, and now we can see that box is just merging in with the rest of this there and creating the shape that I was looking for. As long as it's bigger than the shape that was there before, then I should only see the box cross section. If I did see the other shape sticking through, then I may need to come back to my original profile shape and delete that area out so that this would replace it. In this case it's higher than the original shape, so we can just let that level and the object on it merge. So that's the box. Next, what I want to do is take the shape we've got here and just add on an octagonal shape to that. So if we come back up to the 2D view and we'll go back to the drawing tab, just click on the icon to zoom to fit there. Now we'll come back up to the layers and just switch off the visibility for the components layer there. We'll come back down and I'm going to click the unwrap vectors layer and we'll select that and hit close. Now what I want to do is create my octagonal vectors that we're going to unwrap in order to add to this section here. To do that, we're going to come over and click on the icon here for draw polygon. I'm going to say I want an 8-sided polygon. We'll just make it at 0, 0. And I'm not sure what the radius of the shape is. I know the distance across the flats because we measured the profile earlier. So I'm just going to create a polygon and close, select that and hit F9 to center it. And then we'll scale that shape up. So let's click at Scale Selected Object Size. And the large polygon that I needed, the large octagon that I needed, is going to be 3.5 inches across. So if we hit apply, now I'm going to right mouse click and copy that to the clipboard, and the other polygon I needed was just going to be 1.5 inches across the flats. So if we apply that and close, right mouse click and paste back in the larger shape there. So this is the equivalent of the diameter of the shape here, and this is the equivalent of the diameter of the shape here. So now I want to unwrap those vectors. I'm going to select the small one first. I can only do one at a time. Go to Gadgets, Wrapping, Vector Unwrapper. And then I'm going to select the large one, Gadgets, Wrapping, Vector Unwrapper. Now I'm going to select the two octagons and just delete them. I'm going to select these two shapes and I'm going to hit 9 on the keyboard twice to rotate those around 90 degrees and just move those down to the bottom. Now if you remember, when we unwrap vectors, it puts them on the unwrap vectors layer, but it also creates this drive rail layer as well. If I just close that and go to the layer manager, we'll see that a little bit more clearly. I'm going to right mouse click on the drive rails layer, delete it and delete the data on it. I don't need that. So now I've got my unwrapped vectors on this layer. If you remember, we've got this layer where we created our rails on. So let's come back to that shape or that layer and just select that so that it's current, and I need to create some rails that I can use in the area of the part where we've got this bulge. So let's come back to the drawing tab, click to switch on our guidelines again. I'm going to go to the polyline, and this time I'm going to sketch one from the intersection of these two guides up to the top, click, hit space to accept that, then come back down to the bottom and go up to this point here and space to accept that. Note I went from bottom to top for both of those, and that ensures that they've both got the same flow when we come to use them as rails. Now I'm going to create two more, this time clicking from the end point of that to the end point of that, spacebar to accept, and the end point of that to the end point of that, spacebar to accept. Close the polyline tool and click on the icon to switch off the guides. So now there's one more vector we'll need to create the swept shape that we want for this section, and that's something where we're going to extract it from the original profile we've got here. We're going to use this to give us the depth of our octagon. Now because we're going to use this to give us the depth, on these shapes here I won't need these vertical edges. So I'm actually going to select those, hit N on the keyboard, hover over that span there and hit D to delete it, hover over this span here and hit D to delete that. I'm going to select this cross section, hit D to delete that and D to delete that span there. So I'll say these are just going to give me the octagonal shape. I'm going to use this bulge and sweep that along to give me the depth. So to do that, I'm going to create a copy of my profile. Let's just zoom out a bit by rolling the mouse wheel towards me. I'm going to select this vector, click on it again to go into transform mode, hold the shift key down on the keyboard and click and drag up to the top here. And I'm also going to hold control down on the keyboard so that when I let go, I will create a copy of that. Now if we hit F to fit, I'm going to go into node editing, so we can click on the icon here to go into node editing. I'm just going to put the cursor towards the top here and zoom in on this area. I'm going to come over here and over that cursor right mouse click and say cut vector, and the shortcut key for that is C, so I can hover over this node here and hit C, and if we now hit escape, come back to selection mode, F to fit, you can see I've got 3 separate vectors there. Now I want a straight line in order to give me the full depth of this shape from the center of our spindle. So I'm going to click to draw a polyline, I'm going to snap to the end point there and then snap to the end point there and right mouse click to accept that. I'm now going to select this object, delete it, select this object and delete it, and we can take the shape that we've created here, and rather I want to take the new vector I've created, go into node editing mode. I'm going to select this vector to, this node to be my master location and hold shift and just drag a box around this node here. Then I'm going to hit X on the keyboard and that will align the X coordinate for each of those nodes so that they will basically align with each other. Now I'm going to hit escape, I'm going to select that, click it again to go into transform mode, we'll just zoom in and over the end there, so notice that changes the crosshair. I'm going to hold control, click and drag in order to create a copy for the other end there. Now I'm going to click on the rotary profile, so that is my active layer. I'm going to hold shift and select these 3 lines, click on the icon here to join those vectors and hit join and close. So let's just hit F on the keyboard to zoom out again. So reasonably complex bit of vector editing that I went through quite quickly there. You can always sort of pause and watch the video if you want to follow that along. Essentially what we're looking to do though is end up with just the bulging section of our profile with vertical lines on it that make it the correct height from the center of the spindle, and then these vectors here which are just going to give us the octagonal shape at each end with this lower vector, and in the middle at this point here with the higher vector, and that's why we did that measurement earlier to make sure that we'd get the right curvature when these were unwrapped. Now the last thing I need is an extra bit of data in my rails here so I can accurately position this cross section when we do the sweep. I'm just going to click here and draw a polyline, and I'm just going to snap to the point which is the peak of my profile there and snap down to the bottom here, click and right mouse click to accept that. Now what I want to do is select this vector, hit N to go into node editing, and what I'm going to do is just click on the midpoint and just drag that until it snaps to the intersection of those 2 lines. Then we'll come down the bottom still in node editing and do the same here so that we snap to the intersection of those 2 lines. So notice the little indicator I'm getting there with the 2 diagonal crosshairs going through a circle. So I know now that this has nodes on these 2 vectors that are equivalent to the peak of that shape there. Now I can click to go back to selection mode and just select and delete that line there. It's just a little bit of construction geometry that I use for a moment. Now we can come back to the layer manager, I'm going to switch on the components layer so we can see the grayscales and make that active, so that when we create our swept shapes, the grayscales for those will be put onto the same layer. Let's close this, come down to the modeling tab, and let's go and tile the windows so we can see the 2D view at the top and the 3D view at the bottom. Now I'm just going to come up to Toolpaths and Toolpath Drawing, and notice that this is not available to me at the moment, and that's because the focus is in the 2D view, not the 3D view. So I need to just come down and click to make the 3D view have focus, and now I can come up to Toolpaths, Toolpath Drawing, and switch the wrapping off. I'm just going to undraw the basic shapes level for the moment, and so decorative shapes is our selected level. That's where we're going to create the new shapes that we're going to make here. So let's come over and click on the icon for the 2-rail sweep, and we're going to come over into the 2D view, and I'm going to select this vector at the top and shift and select the vector at the bottom and click on the button to use selection. So there are my drive rails. Let's just maximize the 2D view for a moment and hit F to fit there. You may need to just click in the 2D view to allow the F key to work. Now I need to very carefully position my two cross sections. First I'm going to select this cross section, the lower of the two cross sections, and click on the start point of this bottom vector. What that's going to do is position that cross section at the start and end of those drive rails. Next I'm going to select this cross section, and I'm going to move along the vector until the little indicator shows me there. Notice that little crosshair appears, and that's showing me that it's on the node that we created. So if I click there, I know that it's going to put this vector in exactly the right place in order to represent the bulging area here. So we'll call this octagon and hit apply and close. Let's take a look at that in the 3D view. So we can see that's a very shallow shape there, and we'll really see what that looks like when we add the bulge in order to give us the actual kind of Z dimension for it. So let's create that shape now. So again, we're going to go back into the 2-rail sweep. This time we're going to select this vector here, shift and select this vector here, so the two vertical drive rails, and click on the button to use selection. Just come back out again, may need to select this vector here as our cross section, and we'll call this bulge, and go ahead and hit apply there as well. And if we close that now, we can see the shape we've generated in the sort of 3-axis environment. Let's maximize the 3D view there. I can switch off the octagon, you can see the bulge there. There's the octagonal shape, two being added together. If we go up to Toolpaths, Toolpath Drawing, and take a look, we can see the shape that we've generated there. So this kind of octagon following the shape of our bulge. Now we want to merge that in with our original shapes. So if we switch back on the basic shape, and as long as that shape we've created there is larger than the original shape we had, then again it will just kind of overlap it, and we don't need to worry about what's underneath. If the original shape was sticking through there, then I'd just go back to my main profile shape and delete that section out and effectively replace it with the section we've got up here. Now we're ready to recalculate toolpaths based on new shapes that we've created. To calculate toolpaths, we'll need to switch off the wrapping in the 3D view there, and we can click on the icon to switch to the Toolpaths tab. And because the boundaries are the same for the 3D areas and the 2D areas, and the 2D depths have not changed, I should be able to just click on the icon here to recalculate all toolpaths. That will create new 3D roughing based on the 3D model we have now. The pockets will just be the same as they were before, down to the depths that we specified. That geometry hadn't changed. And then we'll get a new 3D finishing toolpath as well over the new shapes that we've generated. Now we should be able to take these, preview the toolpaths. I'll reset the old preview that we had, so we go back to a solid block. Let's just check that that is the case. And then we can click the button to preview all toolpaths. That'll go through the roughing. Then it will pocket out the areas once that's done that we can see there, and then now it's doing the finishing toolpaths over those new components that we created. And once that's finished, to make sure that this is going to look right, when we machine it, we can come up to Toolpaths, Toolpath Drawing, and go ahead and wrap the Y values again around the X-axis. So what you're seeing here is a good representation in a spire of what the part will look like when we cut it based on the toolpaths that we've created. If that looks right, then just as we did before, we could close this now, select the toolpaths in turn and save them out using the appropriate Rotary configured post-processor. Again, I'm not going to save the toolpaths here, but what I am going to do at this point is save the file so that you have a copy of it in the project folder. So let's go up to File, Save As, and we'll call this Rotary 3D underscore Toolpath, and you'll have a copy of that in the project folder there if you want to take a look at it. So that concludes this tutorial where we've shown you how to import a vector and then create a 3D model and toolpaths that you could machine this part you can see here on a rotary axis setup. Thanks for watching.